Let's do a problem. Here we have to derive a formula to find the sum of interior angles of a polygon and use it to find the sum of interior angles of a 20-sided polygon. So first of all, we should know the meaning of interior angle of a polygon. So here we have a polygon and these angles are the interior angles. Let's discuss the approach for doing this. First, let's take the geometrical approach. For geometric approach, we are taking a polygon with 6 sides, that is a hexagon for example. We can see that this hexagon here is composed of 6 triangles. And by angle sum property, we know that sum of angles of each triangle is 180 degrees. So for 6 triangles, the total sum of angles will be 6 multiplied by 180 degrees, that is equal to 1080 degrees. Angles of the triangles also include these angles. So these angles are also included in this sum here. So if we want to find the sum of interior angles of this hexagon here, from 1080 degrees, if we subtract this complete angle, that is the sum of all the central angles here, then we can get the sum of the interior angles of this hexagon. And we know that angle around the point is 360 degrees. So from 1080 degrees, if we subtract 360 degrees, we'll get 720 degrees. So this is the sum of interior angles of a hexagon. This is one of the approaches of doing this, and the other approach can be algebraic method of finding the sum of the angles. In algebraic method, let S be the sum of interior angles of a polygon and we need to derive the formula for S. Here we will make use of properties of a triangle and that of a quadrilateral. Sum of angles in triangle is 180 degrees and the number of sides is 3, we know. Sum of angles in quadrilateral is 360 degrees and the number of sides is 4. So here we can form 2 solution pairs. First solution pair will be number of sides is 3, that is for a triangle, and sum of interior angles is 180. And the second solution pair we can form for a quadrilateral where number of sides is 4 and sum of interior angles is 360 degrees. So here we can take 3 as x1 and 4 as x2. 180 as y1 and 360 as y2. Now from these 2 solution pairs, we can think of forming a linear equation in x and y. And after forming the equation, we can verify the equation with the help of a hexagon. We know already that sum of interior angles of a hexagon will come out as 720 degrees. With this approach, let's solve the question. With the help of these solution pairs, let's form an equation of the form y is equal to mx plus c, where x denotes the number of sides in the polygon and y denotes s, sum of interior angles. With these 2 solution pairs, we can form 2 equations as. So these are the 2 equations which we have formed and we can solve them and find the value of m and c. Therefore, m is equal to 180 and c is equal to minus 360. Putting these values in y is equal to mx plus c, we will have This implies our equation will be y is equal to 180x minus 360. This implies we have taken y as s is equal to 180 and x we have taken as the number of sides n minus 360, and these will be in degrees of course. So this is the formula we get for the sum of interior angles of a polygon with n sides. Now let us check whether this is true or not. If this formula is true, if we put n is equal to 6, that means for a hexagon the sum should come out as 720 degrees. So let's check this. So this implies s will be equal to 180 degrees multiplied by 6 minus 360 degrees. So that will be s is equal to 1080 degrees minus 360 degrees. So this implies s indeed comes as 720 degrees from this formula. That means this formula is correct. So this formula will be true for a polygon with any number of sides. Let's summarize what we have learnt in this problem. A linear equation is a formula connecting two variables. Finding the variables involved and establishing the linear relationship between them is the key idea behind deriving the formula.